experiment was just to determine the functional group. For benzoic acid, because it dissolved in sodium hydroxide, we know we have carboxylic acid functional group. And if we have like something that dissolves in water and it is neutral, it's not acidic or it's not basic, we can't stop there because it could be any like it could be alcohol, it could be unsaturated hydrocarbon or saturated hydrocarbon, or it could be other functional groups. So we have to continue with some other functional group test. The next functional group test that we are doing, or the first one in the procedure, is the steric nitrate test. Steric nitrate would give like a dark color if the functional group is alcohol. If the compound has alcohol functional group, we get dark color. So I have 3 compounds here: ethanol, hexane, and pentene. These 3 compounds, I'm going to test it with the steric nitrate. So you could see if it's positive, how would it look like? If it's negative test, how would it look like? The first compound I'm testing is ethanol. So I add 3 drops of ethanol, and then I add the steric nitrate. So ethanol was the clear color solution. My steric nitrate is a yellow color, it's like dark yellow color. And especially in the test tube, you will see on the other for hexane that it's actually light yellow color. And when I add steric nitrate to the alcohol, it turns like dark red color. So that's the positive test for alcohol. Now, if I repeat the same functional group test for hexane, I'm going to add 3 drops of hexane in test tube and add steric nitrate reagent. With the steric nitrate reagent, see the color, it's not giving me that red color that I got for the alcohol. It's lighter yellow color just because the orange color is diluted. So I have negative test for hexane, negative steric nitrate test for hexane. The last compound that I want to test is pentene. Pentene, ENE, it has is an unsaturated hydrocarbon, but at the same time, it doesn't have the alcohol functional group. So it's not expected to give red color or that dark red color with the steric nitrate, which it's not. So we have this also a yellow color, which is the negative test for steric nitrate, no alcohol. Okay, we finished the test for the known solution with the steric nitrate. So we already know that ethanol was alcohol, hexane was not alcohol, and pentene was not alcohol based on the steric nitrate test. Now we have 2 unknown here, our unknown A and unknown B. And based on the observation, I want you to record your observation and write the conclusion that is it alcohol or is not alcohol? Because it's a qualitative test. We can't do a lot of like exact which alcohol. All we have to say is alcohol or is not alcohol. Unknown A. This is the unknown A plus the steric nitrate. And I want you to record your observation based on unknown A plus steric nitrate. And the next one, unknown B, is the unknown B plus the steric nitrate. Record your observation for unknown B plus steric nitrate. Now, we are going to continue with the next step, which is the bromine test. What does bromine test do? Bromine test, if the color of the bromine disappears we know that that compound was unsaturated. It's like unsaturated hydrocarbon. Basically, it has carbon-carbon double bond. If the first drop of the bromine, that when you add to the hydrocarbon or to your sample, it does not disappear, that means there is no carbon-carbon double bond. So the positive test for bromine test is if it does disappear, okay? If it disappears. So I'm going to start with pentene. The first test is pentene. Pentene is unsaturated and is expected to have a positive test with the bromine. This is the bromine water, and it's not the most gentle chemical, both of them. So I'm just going to add one drop quickly and look for disappearance of the red color. So here's the observation. It doesn't look red, so it is positive test because the color of the bromine, as I add to this solution, it disappears. So it turns to clear now color. If I add too much, it means that all of the pentene reacts with the bromine, then the color is going to stay. But the first two drops, it did disappear. Next compound, I have hexane. Hexane is saturated hydrocarbon. And if it's saturated hydrocarbon, the bromine water test, it's expected to be negative. And I'm going to add the bromine water test to it. That orange color, it stays. It did not disappear. It just got diluted because, of course, I am adding one drop to this volume. So it is a negative test for bromine water test. It did not disappear. So that's the, I have two unknowns that I'm going to do the bromine test for unsaturation. My unknown A, I placed the unknown A sample in the test tube. So this is the unknown A. When you come to the lab, please work on the fume hood with these compounds. Organic compounds, they are volatile. They can give so much of the vapor that you don't want to inhale. So you want to work in the fume hood. So going back to our topic, this is the unknown A, and I'm adding drop of bromine water, and I want you to check the resistance of the color, if it disappears or it would stay. Record your observation. Adding a second drop. Record your observation, and based on your observation, you could say this compound is unsaturated or it is saturated. Unsaturated meaning it has carbon-carbon double bond. Okay, I think that's enough for proves the point. And the next compound, our next unknown is unknown B. I will add to the test tube. I have the unknown B, and I will add, that's bromine water. I would add drop of the bromine water and look for the color. Okay. So record the color. It disappeared or it did not disappear. And based on that, you would conclude if it has the carbon-carbon double bond or not. This is for unknown A. Thank you. I just want to make sure that the one that stayed with this observation, it was the unknown B. Okay, this was the unknown B because I don't know. I think I said unknown A. This is unknown B. The last part of the experiment is esterification, and esterification is a reaction of alcohol with the reactions of alcohol, which is the reaction between carboxylic acid and alcohol. generates ester. We do need a catalyst of sulfuric acid. That's what we are using as a catalyst today. The alcohol is methanol, and the carboxylic acid that I'm using is the salicylic acid, which the product is expected to be like a pleasant, should have like a pleasant odor as an ester. But esters in general, they have like fruity flavors. You could make esters with different carboxylic acid, different alcohol, and you end up with like different flavor. You could make a strawberry flavor, you could make pear, you could make cherry flavor, banana. The mixture that we are testing today is going to give like a spearmint or the oil of the wintergreen that smell like a spearmint odor, which I'm going to test it. I have measured 0.5 grams of the salicylic acid, and I will transfer into a test tube and add 3 milliliters of the 3 milliliters of methanol, because I need the methanol. I would measure that with the graduate cylinder and get 3 milliliters of the methanol, transfer into the test tube. This reaction could happen, but it's very slow reaction. So that's why we are adding the catalyst of the sulfuric acid. Sulfuric acid is concentrated. So I'm going to add that in the fume, just 5 drops of the sulfuric acid, or concentrated sulfuric acid. And when we have the mixture, we place the mixture of the acid, alcohol, and the carboxylic acid, which in this case is the salicylic acid, in water, and we wait for 10 minutes. For 10 minutes is going to, the reaction would be complete. When the reaction is complete, it has very strong odor. So what we can do, we can take it out and place it in a beaker. The procedure is actually asking to detect the odor. You take this and you place it in a beaker of warm water. Why does it have to be warm water? Because if it's cold water and this is like kind of oily and it can just freeze, the temperature of the water, it should be between 60 to 70 degrees. If it's boiling, of course, the methanol is going to boil. So I'm kind of carefully monitoring this so it doesn't come out of the test tube. It takes like a few minutes for the reaction to happen. And based on the procedure, we keep it for 10 minutes. Okay, it has been 10 minutes and the reaction is complete. I'm going to add some warm water. So basically I'm adding some hot water and cold water to that beaker, small beaker. So I use a beaker holder, transfer some of the hot water into the small beaker. And pour the mixture into the warm water. Okay, this reaction has taken place, and I'm glad that we did this experiment because I had enough of the bromine odor and the pentene odor, which were not pleasant. At least we have a ester with a pleasant odor. The camera does not translate this. I wish you were here, but if you believe me, it smells just like the spearmint or oil of the winter green. And this is the ester that was formed. Thank you. Okay. Another group of organic molecules, the functional group that would be insoluble in water, or if it's more than 5 carbon, but it is less than 5 carbon, would be soluble in water, but it is neutral. So we have to find out what is the functional group. That's for aldehydes and ketones. The aldehydes and ketones, they give like yellow color precipitate with this reagent called 2,4-dinitrophenyletrazine, or 2,4-DNPH is the abbreviation. To test the ketone, which acetone is a ketone, it's liquid, is a small liquid, it is polar, but we are looking for the functional group. It's going to give a precipitate. Precipitate is a solid that is forming when you mix two liquid solution. So I'm adding the DNP first based on the procedure. Then I'm going to add a few drops of the acetone to this solution. So this is a yellow color, but still is a solution. If it precipitates, it would turn cloudy. So that's what we are looking for, formation of a cloud, the solutions, cloudy mixture. So now it turns cloudy. This is a positive test. You see, I want you to see the difference. This is a cloudy, it's not transparent anymore. It is a cloudy mixture, a precipitate, yellow color precipitate forms, positive test for ketone. And we are going to use a unknown for this mixture. Actually, I'm going to use two unknowns. My unknown one, which is the, I have an unknown here, unknown B, and I have one more unknown here, is unknown A. So I have unknown A and unknown B. To the unknown A, I will add the reagent. So I'm going to add the reagent. The 2,4-dinitrophenyletrazine reagent. And I want you to, again, pay attention that is the transparency. It's not colorless, it's yellow color, but it is transparent. But when I add the unknown compound, I want to see if it stays transparent or if it turns cloudy. If it turns cloudy, that would be a positive test for ketone. So in this case, it turned cloudy. I want you to record your observation. Okay, good. For unknown B, we also have an unknown B. For the unknown B, I would add the reagent, the 2,4-dinitrophenyletrazine, the 2,4-DNPH again, plus drops of unknown B. When I add the unknown B, in this case, see the consistency or is not changing. There is no precipitate forming. And if no precipitate forms, that means is a negative test for the 2,4-dinitrophenyletrazine test. And that is going to give us negative test because the precipitate did not form. So we don't have ketone or if the precipitate doesn't form. And thank you. That was a very short experiment for ketones and CO double bonds in general.